Hey there, good day. I'm Nabil, a simple engineer. Let us see how data is handled in Java. Without further ado, let's jump straight in. Data types. If you read them closely, the data types are just different types of data. You might be wondering, it is just like saying tomato, tomato. What's the point? Well, no. Let's break it down. Data is represented in various ways, depending on what the data itself is. In real world, if you ask a person to write a number in a notebook, he'll write it down. But wait, what's data got to do with this? Before we get there, let us understand what data is. Well, data is just a piece of information about something which will be understood by somebody. Everything you and I speak is data. Everything you and I read every day is data. The color of a bottle is data. Time in your watch is data. The name of the vegetable that you buy is data. And by the way, the video that you're watching right now is just data, which is by definition has information about something. In the example that we took, the number which the person wrote down is a data because the number is just some digit which you and I can understand. The book in which he wrote it is also data because the book itself has some information, which is the number in this case. By nature, data is everywhere. In fact, in 21st century, whoever controls the data controls the crowd. In the world of programming, every software, every product, every program at its core is just playing with data. To make this play of data meaningful and give it a structure, we have something called data type. Different data types have the ability to store different kinds of data. Well, how different can the data be? Let's understand it the Java way. Here, if I want to write a number, I'll use the numeric data types. For example, for a simple number, we have int. For a slightly larger number, we have long. For a decimal number, we have float. For a precise and larger decimal number, we have a double. For a simple smaller number, we have a short. For a simple smallest number, we have a byte. To write a statement, I'll use a special data type in Java, and that's a string. If we chop the string by each individual letters inside, we have a character data type. These were the basic forms of data that JDK ships with. Let's go beyond these. To represent data which is unknown to the JDK, the likes of which only the user is knowing about, we have something called user-defined data types, which is basically the kind of data structured by the user itself. For example, to represent a real thing like a banana, which by itself has multiple attributes like color, size, species, ripeness factor, etc. For this, we have something called class. In such a data type, the user, i.e., you, as a developer, are responsible to design the class however you want. You can create a banana having all of its attributes. In a class, you define what you need, and the JVM will do the job of holding the actual data inside it. You can choose to add new attributes or remove existing ones. That's totally up to you. The class data type has special superpowers. In OOPS paradigm, it acts as a template for object creation. It can possess behaviors using methods. To represent constants, we have enum. Enum is also a special data type which is primarily user defined. Enum is just another class in Java but with its superpower of immutable nature and wide accessibility. You can store constants in the enum by creating an enum data type using the enum keyword. Over here, you just define the constant values and the JVM will create a special type of class internally and store these values. The enum values are internally public static final, which means it can be accessed directly using the class. For example, for an enum of the type blood group and its constants as positive, negative, etc., you can call or invoke or get the enum constants by directly stating blood group dot A positive, B positive, etc. Alright, these were the types representing a singularity. What if we want to store numerous such data? What if we have to represent multiple bananas? We don't want to declare each fruit manually by writing banana 1, banana 2, although they possess similar data? Well, no. The OG way of handling exactly this requirement is to use an array. By definition from the Oxford University, an array in general world is a large collection of things, exactly what we need to store multiple bananas. Getting back into the programming paradigm, to do this, we use an array like the following. This array data type works on storing its data at continuous memory locations. Since they are continuous in memory, the elements within are stored one after the other. Each element is stored in a unique position. The position here is known as an index, which is how we access the elements within an array. In real world, there's more, so much more. For example, how do we handle duplicate elements? How do we handle pairs of data? How do we handle if the data keeps on increasing? How do we handle huge amounts of data in a simple and manageable way? As software requirements of handling huge data demanded more flexibility, more types of data and the mechanisms to handle such data were introduced. Mechanisms such as streams, collections, etc. But that will be for another time. Until then, keep on practicing, keep on experimenting.